Hey, what's going on, everyone? So we're starting week 3, and we're starting to get into some of the guts of the programming, and started getting some pretty cool stuff. I just want to say that I've graded a lot of the assignments from last week, and you guys have done really, really well. It certainly appears that you guys have reviewed the material and studied that pretty hard, and taken note of the items that I talked about in terms of formatting and the modular design and all that. So you guys have done really, really well. So this week we're going to be talking about some flow charting and making decisions in our code. So if you look at page 94 in your text, it starts talking about flow charting and how a lot of that stuff is put together. Page 96 in your text talks about the specific flowchart symbols that we're going to be using. Now, different flowchart applications have different symbols, but these are the basic symbols, and these are the ones we're going to use in this class. Of course, the first symbol is an oval type, and that's the start and the end of your program. The rectangle is the process symbol. The parallelogon there, I guess, is what that is. That symbolizes input and output. That is, variables or values coming into and going out of your program. And then the decision block is that diamond that you see there. Now that's going to get a little interesting later on. Now the flow charting utility that UMUC has provided us is a program utility called Raptor. I'm not a big fan of it because there are a lot of things that we do in this class that Raptor just doesn't handle very well, and we'll get into that a little later. So take a look at the flowchart, figure 2.6 on page 97 of your text, and compare that to the code that symbolizes in example 2.10 on page 98. Now you'll notice that the flowchart does not at all resemble the modules in our module design. Our hierarchy chart symbolizes the modules and how they interact with one another, but the flowchart is nothing like that. The flowchart symbolizes the flow of execution in the program, and of course you can go from your main module to a module beneath that and take care of a few things and go back to the main module and then come back to or go to a different module below that and then go back to main and then go back to the first module you went to. The point is that the flowchart is going to look totally different from what from the hierarchy chart. So also in this week we're going to be starting getting into control structures, and effectively what the control structures do is determines where the processing is actually going to take place and what direction it's going to be going. So most of our code is going to be a sequential structure, which means that it goes from one line to the next line to the next line and executes those commands in sequence. Hence the term sequential structure. So in addition to that, there's also a decision structure, which basically is a yes or no, for instance, or true or false, and it will branch your processing from that part of the code to a different part of the code. And then, of course, there's a loop structure, which if it meets a certain criteria or satisfies a certain condition, it will enter the loop, and then it will execute that loop a certain number of times. Hopefully that loop is not infinite, and we'll talk about that a little later on. But it'll go through that loop the proper number of times to satisfy the need of the code. So one of the control structures that we use is called the if-then statement, or the if-then else statement. And the if-then statement by itself is a single alternative structure, and then the dual alternative structure is the if-then-else. So if this condition is met, then do this. I've just noticed that I've misspelled then in my second bullet there. I do apologize for that. If this condition is met, then do this. If this condition is not met, then do this. So that means that test for this, then do this, else do something else. So, and then there's also the multiple alternative structure, which is, for instance, a case statement, and we'll get into that here in just a few minutes. But that's going to be looking at more than one condition. So if you look at the flowcharts for these on pages 113 and 114, let me get there myself. It's very important that you understand how these flowcharts are constructed, because as I've mentioned, Raptor is not very good at handling some of these, and certainly the case statement. So let's look at let me see if I can find the control structure for the case statement real quick. So this is getting ahead just a little bit, but bear with me just a moment. If you look at figure 3.7 on page 138, this is the flowchart structure for a case statement. And Raptor, at least in my experience, I've been unable to get Raptor to duplicate this type of structure. So if you when you get to a point that you'll be using a case statement in your code, and you will be doing that, it's best that you get entirely away from Raptor and use some other formatting utility, for instance, in PowerPoint or Windows. Windows also has some, Word has some flowcharting utilities in there that you can take a look at. So as we start delving into some of these control structures, some of the control structures, of course, will be testing the condition of variables, for instance. There are other things that we test for, but primarily in this class we're going to be testing for the condition or the contents of a variable. So if you look at the table on page 120 in your text, that is the list of relational operators that we'll be using in our syntax. Now, different programming languages have different syntax on how to test for a lot of these things, but this is what we'll be using in this class. Of course, and a lot of these are pretty familiar to us: less than, greater than. Not equal to. If you've seen code, you probably have seen a lot of these things. Now, one very important thing to note is the second one from the bottom, is equal to, is a double equal sign. And one very common mistake that people make is that they will use a single equal sign when trying to test for the condition of a variable, and that equal sign will actually set that variable to that test condition rather than testing the condition. So it's very important that you use the double equals when you're trying to test the condition of that. There are also logical operators, the and, or, and not, and that's on page 123. And again, this has some examples, pretty good examples on how these are used in the code. And then, of course, there are compound conditions where we combine those relational operators with the logical operators for some pretty complex code that'll do some pretty cool testing. And we'll see that a little later on this term. So take a look at table 3.2 on page 128 of your text. This is exactly what I was talking about. This is the hierarchy of operations when we do those combinations of mathematic and relational and logic operators. This is the order that all those things take place, and it's very important that we understand how the order of those events, so our code performs the way it's supposed to. And now I will definitely admit that it takes some experience to start perfecting some of these things. I mean, these things for the folks that have never laid eyes on code, these can be some pretty tough concepts, and that's okay. I mean, the assignments that we're going to be doing here are certainly not going to get anything of any kind of great complexity, so don't worry too much about that. So we're going to get back into the if then else statements. And looking at somehow how these things are used. All right, so this is example 3.2 on page 117 of your text. If you flip back to that real quick, now you'll notice that I've changed this a little bit to encapsulate all this in the proper code syntax that we've been using in this course and stuff that I've been stressing with everyone to this point, to encapsulate that in the main module and then in program. So we're going to declare a couple of variables here, which isn't done in the example, but I'm going to declare cost as a float and revenue as a float, and then we're going to display out to the user enter total cost, and they're going to input the cost at that point, and then we're going to display out to the user enter total revenue, and then the user is going to input revenue. And then at that point, the code is going to test if the value in the memory location for the variable amount is greater than 0. If it is greater than 0, it will come into this the if statement. It will say then set profit equal to amount. Now, if amount is equal to or less than 0, it's not going to go into this if portion at all. It's going to go down here and create set loss equal to amount. And of course, in both cases, if it's greater than 0, it's going to write the profit is with a $sign, and then the value of profit. Else is going to write the loss is with a $sign, and then the content of loss, and then in program. So as I mentioned a few minutes ago, we're going to get into some the possibility of using some pretty complex control structures, like some nested if-then statements. If you look at example 313, it does a little bit of that, where it creates an if-then-else statement, and then there are if-then-else statements inside that. And it's pretty cool how that stuff works. And if you read very carefully at the bottom of that example under the what happened section, it explains precisely how that works. Now let's look at the case statement I was talking about. If you look at example 314 on 137, this talks about a case statement scenario. So I've got that actually written in code. So let's take a look at that in Notepad real quick. Okay. So again, I've modified this a little bit to enclose all this in a module. But I've declared store as an integer and rating as a character. And then we write out to the user enter score, and the user is going to enter the integer value of score, and so at that point it's going to enter the case statement, and if the value of score equals 10, then it's going to set the integer of rating to an A, and likewise if the value of score is 8 or 9, it's going to set rating to a B, and if score is 6 or 7, it's going to set it to C, and then 1 through 5 is going to set it to a D. And then it's going to end the case statement, and it's going to write the value of rating at that point. So that's kind of how the case statement works, and you'll see how how we can use that in some of our code later on. And again, the flow charting structure for that case statement is in Figure 3.7 on page 138. So now the remainder of this, sections 3.5 and 3.6, are some pretty important aspects. I'm not going to get into a lot of the detail on that. I'll let you guys read through that, and it's very important in these sections and in all the sections that you look at the examples and review the examples and study those very hard. And as I've mentioned to a few of the students in the class, I don't say this very often about some of the or any textbook, but this textbook actually does pretty good with their examples. So if you take a look at those, you could really see what's going on. Before I move on, I wanted to take a look at Raptor real quick and show you how that works. I have captured, I actually flowcharted the code, my code for assignment 1. So let's take a look at that real quick. Okay, so this is Tony Baird's code to solve assignment 1 that you guys worked so hard on last week, and again, you guys did a great job solving those problems. So, of course, with modular design, we're going to have our main module as our opening module, identify that, and going to identify all the variables that I'm going to use in this code. And I'm going to have a length and width variable for all 4 rooms for a total of 8, and then have flow variables that will contain the area of each room, and then a final flow variable that will contain the total area. So at that point, I will call my input module, come down here, and again, I've stressed this before. It's very important to me, and in future programming for you guys, to be very specific about what the user is supposed to enter. So rather than, and the book is guilty of doing this on a few examples, and I'm not very happy about that. But rather than writing instruction out to the user saying enter length and width of room 1, there's always room for error. Now I don't know how often you guys deal with users using computers on a day-to-day basis, but not all users are computer savvy, and not all of them can do things on computers that other people can. So that being said, it's always a good idea to me to be very specific what the user is supposed to enter. So have the user enter the length and the width of each room, and that's done in the input data module. And of course, once that is done, it's going to go back up here to the main module, and that line is completed. So it's going to go to perform calculations, and it's going to come down here, and the first line is going to set area room 1 to room 1 length times room 1 width, and it's going to do that for all 4 rooms. And then finally, it's going to set total area to the sum of all the room areas. Easy enough. So once that calculations module is done, it's going to come back up here and go to call output results module, and then at that point it's going to print out room 1 is the area square feet, and I've actually missed a quotation mark right there, so please forgive me for correcting my code while I'm in lecture here, but I'll take care of that real quick. And of course, hopefully you guys can see what the output is going to be when this program runs. And then finally, the last line will be the total area of the house, or that should be those 4 rooms will be total area plus square feet. So I took this code actually and used Raptor to flowchart that, so I wanted to show you guys that as well. So give me just a moment. Okay, so let's take a look at my code if I can find that again real quick. Let me see if I can split this and show you exactly what's going on. Okay, sorry for the video jumping all over the place there for just a moment. But this flowchart does exactly what this code what this code over here does to solve that problem of getting the area of 4 rooms and totaling that together. So as you can see, as I mentioned earlier in the lecture, the flowchart is not going to look anything at all like the modules in our code. So the first block I have here, of course, this is a block to get a value from the user. If you take a look at that, it has enter the length of room 1, and it places that in the variable room 1 length. And likewise, it does that for the width. Enter the width of room 1 and puts that in room 1 width. Okay, so I do that for each one of these. There's 2 per room to get the length and the width, and then this block is it's a processing block that I need to open, and this will set the variable of area room 1 to room 1 length times room. Oops, that should be room 1 width. Let me change that. Sorry about that. And likewise for these, I'm going to make sure, yeah, room 2 length times room 2 width will go in area room 2. So it does that for all 4 of those to get the area of the rooms. And then the last one will be total area will equal the sum of area room 1, area room 2, area room 3, and room 4. And then finally, it's going to output that information to our display. It's basically going to print room 1 is the value of area room 1 square feet, and I have that for room 2 and room 3 and room 4. And then finally, this has the total area of the house, or the 4 rooms, and it displays the contents of the total area variable square feet. Okay, so let's run that, and I'll show you how that works. Let me shrink that. Okay, sorry about that again. All right, so let's run this and see if we can get this to run, and I'll show you how this performs. So we'll click on the Run button, and I'm going to enter, I guess, 12 for every value here. I'll mix it up a little bit. Oops. Okay, so you'll notice that that as it when I finished entering all the variables, it went into these other blocks down here to process that data and to calculate what the other variable contents were going to be, and it put all that in this area here on the left, and then it output exactly what we told it to output. So that's the kind of cool thing about Raptor, is that it kind of lets you run code of sorts, but it is not this code. So you're certainly welcome to play around that if you like. I really I warn against getting Raptor on the axle on getting a lot of this stuff to work with Raptor, because when we get into, as I mentioned before, we get into case statements and things like that, it's just very, very difficult to get that kind of stuff to work. My recommendation on the flowcharts, I would definitely recommend trying to get that to work with Raptor, but use utilities, as I mentioned before, in PowerPoint or in Word, and include that in your assignment. So now, of course, with that assignment, just like your pseudocode, all of that is going to be contained in one Word document that you're going to submit in your assignments folder. And that's about all I have for this week. So if you guys have any questions about any of that, or if I've missed some detail in the reading material that you're specifically interested in, let me know. And good luck on the next assignment. Take care. Bye-bye.